In this video, we're going to learn about reactivity and acid-base chemistry. So a strong acid and a strong base neutralization reaction will result in there just being a neutral salt and water. For example, if you have HCl, a strong acid, and NaOH, a strong base, they give rise to table salt, NaCl, and water. And this is just a double replacement reaction where the H plus and the OH minus get together and form HOH, also known as water. And actually, if you're talking net ionic equation, that's really all that happens because sodium ions and chloride ions start off aqueous and will remain aqueous. Although if you evaporated off all the water, you would be left with crystallized salt. But if we look at any salt, we can actually tell what acid and what base reacted to form this salt. So for example, if we have magnesium nitrate, we can take that Mg+2 ion and we can say, all right, which is it? Is it the H plus or the OH minus? Oh wait, this is positive, so it's going to be hydroxide that was with it. And if it's a magnesium 2 and a hydroxide -1, then it's MgOH2, magnesium hydroxide, that reacts with, well, if I've got nitrate here, the nitrate is NO3 minus, and the H plus has to come into play. So I've got MgOH2 and HNO3 that react together to give MgNO3 2. And yes, I know you need two equivalents of nitric acid to make this happen, but bottom line is, if you're forming magnesium nitrate, you can do that by reacting magnesium hydroxide with nitric acid. Next, I want to just say that salts that have an acidic cation and a non-basic anion will form acidic solutions. So, for example, NH4Cl is going to form an acidic solution when it dissolves in water. And we can tell this just by looking at the acid and base that could have reacted to form it. So for the acid, that's going to be HCl, that chloride negative with an H plus. This is a strong acid. And the ammonium came from NH3. You could also say NH4OH. It's another way of saying it, but that is just another way of saying kind of like NH3 plus H2O would be NH4OH. But however you see it, whether it's NH4OH or NH3, you know this to be a weak base, whereas you know HCl to be a strong acid, and just the overall greater acidity than basicity results in you having a more acidic solution of NH4Cl. And if you were to look up the Ka of NH4 plus, there is a Ka. Don't know it off the top of my head. If you were to look up the Kb for Cl minus, that's going to be extremely, extremely small because chloride is the conjugate base of a strong acid. All right, next, we have that salts of a non-acidic cation and a basic anion will form basic solutions. So with NaCN, we can say that this came from HCN, which is a weak base, or sorry, a weak acid, and that reacted with a strong base of NaOH. And so the overall greater basicity than acidity that we had results in NaCN forming solutions that are weakly basic, because that CN minus, if you look up its Kb, it's got a noticeable Kb. Sodium ions are not going to be acidic by contrast, not to any noticeable degree. So that is all for this video. Hope it's been helpful. Feel free to leave any questions or comments in the comment section below. Thanks for watching.